Okay, so number two, this question is asking us a vocabulary term. It wants to know if every relation is a function. Okay, so I have the textbook also pulled up, which you can just get there from question help in textbook. But in the textbook, it shows you the formal definition of relation and function. So on the first page, it shows you that a relation is a correspondence between two sets, X called the domain, Y called the range. Each element from the domain corresponds to at least one. So there is at least one that they're mapped to. That's what a relation is. Now, if you go over a couple pages, you get the definition of a function. So a function from X into Y is a relation. So a function is a relation that associates each X with exactly one. Okay, so the difference is this one has exactly one, and over here, this one says it is paired with at least one. So this at least one would make not all relations are functions, but every function going backwards is a relation. Here's an image down at the bottom showing you that each of these X is going to one value to the right. So this would be a function, and it is a relation. All of these are relations. However, this relation here, where this 240 is going to 12 and also going to 20, this would not be a function, but it is a relation. So to answer this question, it says every relation is a function. Here we have a relation that is not a function because a function says each X element has exactly one Y. And you can see here, these X elements here, one of them has more than one Y. So that means that this is not a function, however it is a relation. So the fact that it says every relation is a function is false. However, if it had said every function is a relation, that would have been true. Now, this next one we want to state the domain and range. And again, if you go back to this text, there are several terms, go back to the first page, that correspond to domain or range. So, let's look at a few of them here. Y depends on X, so if you see dependent, that is Y. Independent would be X. It is also helpful to think input as X, Y as output. Okay, so you have input, output, dependent, independent, domain, and range. All of those terms refer to X or Y. Now, here and in general, we have X on the left, Y on the right, alphabetical order. So X would be my domain, Y is my range, and we want to match these together. So the brother, Gavin, Adam, Heath, and Buck, that will be my domain. So it looks like B matches the domain. Now the range, the sisters, Morgana, Simone, Diana, Georgie, and Annabella, looks like B matches as well. So this is going to be the one that lists all the elements of the range and all the elements of the domain together. And then we want to know, is this a function? So just like the image we saw in the text, when we saw two lines coming from one of the elements in the domain, that is not a function. So we can see Adam has two sisters. Now if each brother had one sister, that would be a function, but because Adam has two sisters, this domain element has two range elements, it's not a function. So A and B say it is a function, so out of C and D, because we say it's not, says it's not a function because the element Adam in the domain corresponds to more than one element. And here is the definition of what it means not to be a function.